So today we're going to look at the basics of vectors in a coordinate plane. So a vector has a length, which is called a magnitude, and a direction. Now this vector has an initial point, which is called your tail, and then it has the arrow in the direction of the terminal point, which is called your head. The notation for a vector is always either U, V, or W in lowercase, and it's in boldface. Then you can also write a vector with this notation where notice the initial point is at A and then the arrow, the direction of it, goes to the terminal point. So both ways are ways that we can write vectors. Now a vector is written in vector component form, which is head minus the tail. So you're subtracting your initial point from the terminal point. So the head minus the tail, and you're subtracting the corresponding parts. And notice the notation. The points are with parentheses, but a vector is with this notation. That tells us that it's a vector. So x2 minus x1, y2 minus y1, and that will be your vector. Now notice here, it says an arrow has an initial point at 2, 3 and a terminal point at 7, 5. What vector does it represent? So the first thing we want to do is we want to kind of draw this vector so we know the direction. So notice this is at 2, 3, and 7, 5. So this is the direction. Now it's important to know where that vector lies because later on we're going to have to find the angle. And the angle will determine where the vector is at. So you do want to make sure you know how to do that. So here they're just asking for the component form. So remember, head minus tail. So the terminal side minus the initial. So 7 minus 2, 5 minus 3, and you get 5 minus 2. Make sure that it's in vector form. The next one, it says an arrow has an initial point at 3, 5, and it represents the vector negative 3, 6. They want us to find the terminal side. So the terminal side is our x2, y2. So what we're going to do is we're going to set an equation. The vector is equal to the head minus the tail, so x2 minus x minus 3, y2 minus 5. And then we're just going to set each corresponding part equal to the correct part. So x2 minus 3 is equal to negative 1. We'll solve it. That gives us 0. y2 minus 5 is equal to 6. We'll solve it. It equals to 11. So our terminal side is at 0, 11. Let's try the next one here. If P is a point at 4, -3, and you have a vector that's represented by this, that tells us that this is our initial point because it's starting at P. We're looking for the terminal point. So notice it's kind of the same question on this previous one, but they gave us different information. But we're still going to do the same concept. So remember, head minus tail. So we're going to set the vector equal to x2 minus 4, which is the head minus the tail, y2 minus a -3. And we're going to set each corresponding part to what it's supposed to equal. So x2 minus 4 is equal to 2. We'll solve, which gives us 6. y2 plus 3 is equal to -4. That gives us -7. And that's our terminal point. It's at 6, -7. And notice these are parentheses because this is a point. The next one is if Q is a point at 4, -3, and PQ is my vector, and it represents this vector 2, -4, find P. This time, P is the initial point. They're giving us the terminal point. So remember, head minus the tail. So again, set up our equation. 4 minus x equals to 2, because we're going to set it equal to the corresponding part. -3, which is our head, minus our tail. And I apologize, I put a 2 here. That should be a 1. So we're going to go ahead and change that all to a 1 because we are looking for the tail here. So we're going to set each of them. So here we're going to solve. We get x is equal to 2. And here we're going to solve. We get 1. So our initial point is 2, 1. Now, how do we find the length, which is called our magnitude of the vector? So the magnitude, if you look at it, and this is the notation, we can use a bar like this, make sure that it doesn't mean absolute value, or they can actually use a double bar. So depending on the book, they'll use 1 or they'll use 2, but it still means the same thing. It means the magnitude. So notice it's kind of like the distance formula. Remember, the length of this vector here is going to be the distance formula. So you're subtracting the x values and squaring them, and then adding it to the difference between the y2 minus y1 squared. Now, if they give it to us already in component form, this is if they give it to us given the 2 points, but if they give it to us in component form, all you have to do is kind of like the Pythagorean theorem to find out that hypotenuse. So the magnitude is the square root of a squared plus b squared. Let's try some problems here. So here, find the magnitude of the vector, and they give us the 2 points. So we're going to do head minus tail, so 5 minus 3 squared plus 2 minus a negative 4 squared. That becomes a positive. So I get 6 squared here, 2 squared here. So 4 plus 36, I get 40. So the square root of 40 is our magnitude. Let's try the next one. It says find the component form and magnitude of the vector v that has an initial point and a terminal point. So I'm going to find the magnitude here. So it's going to be and I put this in a different form, so let me just rewrite that again. So just to keep it consistent, it's going to be our head minus our tail squared plus our head minus our tail squared. So notice we get -1 minus 4, which is going to give us a -5, but it could be just 5 because it's going to be squared, which is 25. The negative and negative become a positive, which is a 12 squared, is 144. And the square root of 169 is 13. Now, that's one way to find the magnitude. I could have found the component form first, which is head minus tail, so -1 minus 4, and 5 minus a -7, and we would have gotten this. I could have used this one to find the magnitude, because it would be a squared plus b squared. And notice that I'm going to get the exact same thing, which still gives me 13 as my magnitude. So notice that we could do it in 2 different ways, depending if they give us a point or if we get the component form, the actual vector. Now, vector operation is just that. You're going to be adding or multiplying numbers, or adding numbers or subtracting them. So when you have 2 vectors and you're adding, all you're going to do is add the corresponding parts so that you get a new vector, or the same thing for a negative. If it's a scalar, that means it's a number that's being multiplied into that vector. So don't make it more complicated than it is. All you're doing is literally corresponding parts. You're either adding, subtracting, or you are distributing that 2 into that vector. So notice here it says u plus v. So this is my u plus my v. So I'm going to add my corresponding parts. So -1 plus 2, comma 3 plus 4. So it's 1, 7. The next one, notice you're multiplying by a number. So I'm going to distribute that 2. So we get -2, 6 as a vector. Minus, I'm going to keep it as a minus. I'm only going to distribute the 3. So I get 6, 12. And now we do the operation. So -2 minus 6, 6 minus 12. And we get -8, -6 as our new vector. Notice the next one. This is our v is equal to this vector, -2, 5. And w is our vector 3, 4. So here it says 2 times. So we're going to multiply. We get -4, 10 as our new vector. Here we're subtracting them. So 3 minus a -2 and 4 minus 5. That will become a positive, which is going to give us 5. And 4 minus 5 is -1. And that's our new vector. Notice the next one. The first thing we want to do is distribute that 2 before we do addition. Remember order of operation. So that's going to give us 6, 8. And then we can add the corresponding parts. So -2 plus 6 and 5 plus 8, which we would get 4 comma 13. So that's vector operation in component form. Now, unit vector, okay, is a vector that has the same direction as the v. And all you have to do is get the vector and divide it by the magnitude. So here, notice that they give us the vector. We're going to find the magnitude, so the square root of a squared plus b squared, so we get the square root of 29, over our vector. And then we can just divide both of them, and that is the same thing. That's our unit vector. The next one is negative 3 comma 2 is our vector here. So first thing we want to do is our magnitude, which we get square root of 11, divided by our actual vector. So negative 3 over square root of 11, 2 over square root of 11. Let's look at the next one, linear combination. So what we did was component form. This is a different form to write it. And this linear combination is called in rectangular coordinates. The I represents the distance with the X and the J here with the Y. But you're still doing the same thing. It's head minus tail and head minus tail for the other part. The only thing is that you need to tag along the I and the J instead of putting it in those special brackets. So let's look at this one. It says, let U be the vector with the initial point and a terminal point, write in linear combination. So of the standard unit vectors of I and J. Okay, so head minus tail. So I'm going to put my vector is going to be negative 1 minus 2I plus 3 minus a negative 5j. So here we get negative 3I and plus 8j. Now notice, this is the linear combination. If I asked you in component form, this would be negative 3, 8. So notice the difference, linear combination and component form, but you do the same thing. So here, let V be the vector for the initial point and our terminal point. And again, they want it in linear combination. So head minus tail, so negative 2 minus 3, and 5 minus a negative 1. So we would get negative 5I plus plus 6j, and that would be our vector. The same thing with the operations. So the one that we did before was the operation in component form. Now we're going to do operations in linear combination form. But you do the same thing. You have to add the corresponding parts. So notice here for this one, it says v plus w, the vectors, to add them. So 5I plus 4j plus 6I minus 9j. We're going to add the 5 plus 6, and we get, and I apologize, that's an I there. It should be 11I, and then 4 minus 9, you get negative 5j. And then v minus w, make sure that to distribute. So 5I minus 6I is negative I. 4j plus 9j is 13j. On the next one, we're multiplying by 6. So that would be 30I plus 24j. On the next one, we're multiplying by negative 3. So negative 18I plus 27j. So that's good. So it's the same concept as component form. You're just writing it in a different way. Now, writing a vector in terms of its magnitude and direction. So this is another way we can do it. So here, we would write the vector as the magnitude times cosine of the angle, because sometimes they may be giving us the magnitude and the angle, and they want us to write it in linear combination or component form. So it is the magnitude cosine of theta, I, because remember cosine back when we were doing trig, that represented our x, and then sine represented our y. So plus the magnitude sine of theta j. Now it's important that you have the theta to be in degrees. Make sure your calculator is in degrees because you will be using that. Sometimes they may ask you to find the actual angle. So finding the angle, instead of trying to do this formula and kind of going backwards, it's a lot easier just to do the tangent of theta and put b over a. So notice here, find the component vector with the directional angle of 120 and magnitude 8. So notice they're asking for the vector. And here I don't have the points, but I do have the magnitude and the directional angle. So 8 cosine of 120 plus 8 sine of 120. We know cosine of 120, which is negative a half. Sine of 120 is square root of 3 over 2, and we work it out. Now for this one, it says find the directional angle of vector 3, negative 3. So remember 3, negative 3 would go this way. It has to be in quadrant 4. So when I do tangent of theta, I'm going to notice this is a solving one. So theta, that's in quadrant 1, would be 315. Now this one is at negative 2, 3, so it's in quadrant 2. So when we do the tan inverse, remember the tan inverse has a restriction. So it's going to give us 56.3, but that's in quadrant 1. So what we're going to do is we're going to take the 180 minus the 56.3 to give us the angle that we need. And then in vector here, negative 4, negative 1 is in quadrant 3. So when we get this is not one of our special ones, so we're going to put in our calculator and we get 14.04. But because we need it in quadrant 3, we're going to add this. So this is our angle, our directional angle. I do want you to complete this box here, and you can go ahead and do the assignment.